Assalamualaikum dan salam sejahtera. Hi guys, see you again. Now we are going to learn about new chapter, which is chapter 2, atomic structure. In this chapter, we have 3 subtopics and we are going to focus on the first subtopic now, which is 2.1, Bohr atomic model. So this is the first part of 2.1. So guys, let's start. Alright guys, so in this part, we are going to look at Bohr atomic model, and then we are going to learn about electron energy level, whether at energy state, ground state, excited state, and we are going to calculate the energy difference when the electron make a transition. Alright guys, so now we look at the wave nature of light. So in this wave nature of light, we have 2 variables, which is frequency and wavelength. So what is frequency? Frequency is the number of wave undergoes per second. The unit of frequency is per second, or normally you biasa tulis as hertz. And then for wavelength is distance between identical point of successive wave. So the unit of wavelength, either you use nanometer, picometer, Armstrong, meter, or etc. Okay, but in our lesson for chapter 2.1, we are going to use our unit for wavelength is nanometer or sometime meter. So this is the relationship that relate frequency and wavelength, which is C equal to nu times lambda. So this is the symbol of frequency we call as nu, and this is the symbol of wavelength that we call as lambda. So this is the first formula yang you akan jumpa dalam chapter ni. So after this kita akan jumpa lebih banyak formula in this chapter. Okay, actually C refer to the speed of light. So the value of C is constant 3.0 times 10 power of 8 meter per second. So nilai C tak perlu hafal. Nanti I will show you dekat mana you boleh dapat list of constant value. Okay guys, so next we are going to learn about Bohr atomic model. So Bohr is actually the name of the scientist. Nama penuh dia adalah Niels Bohr. So actually Niels Bohr suggested a model for the hydrogen atom that predicted the existence of line spectra. So Niels Bohr also used the Planck's and the Einstein idea about quantized energy. So dengan itu, kelas, Bohr telah mengeluarkan beberapa postulate. So apa itu postulate? Postulate ni macam fatwa. Kalau dalam orang Islam biasa dia ada fatwa kan, ataupun sebagai macam tanggapan, anggapan dia saja. Okay, so we have 4 postulate of Bohr. The first one adalah electron move around the nucleus in a fixed circular orbit. It means that elektron akan bergerak mengelilingi nukleus dalam orbit yang tertentu. Contoh seperti bumi mengelilingi matahari. So ini adalah anggapan Bohr lah. Okey, kemudian yang kedua adalah electron at certain energy level has certain amount of energy, or the energy is quantized. Quantized ni maksudnya dia ada tenaga yang tertentu jika dia berada pada petala yang spesifik. Biasa you pasti dengar kan petala. Okay, I will explain more about the second postulate after this by using diagram. Okay, the third one we have electron move in an allow energy state will not absorb or radiate energy. Maksudnya kalau elektron tu hanya bergerak mengelilingi nukleus, okey, dia tidak akan menyerap atau membebaskan tenaga. Dia hanya mengelilingi nukleus sahaja. So tidak ada perubahan tenaga yang berlaku. Okay, and the last one, the fourth postulate is energy is emitted or absorbed by an electron as it change from one allowed energy state to another. Dekat sini baru dia akan berlaku perubahan tenaga jika elektron tu make a transition from one energy level to another energy level. Contohnya kalau elektron tu berada pada petala yang pertama, kemudian dia berubah kepada petala yang kedua, ketiga atau keempat. So dekat situ akan berlakunya perubahan tenaga, whether dia akan absorb maksudnya serap tenaga, ataupun dia akan bebaskan tenaga. So for the third and fourth postulate, I will explain after this more by using a diagram. Okay guys, so now I will explain to you by using a diagram how to understand the postulate of Bohr. Okay, look at this diagram. Okay, this diagram I will explain to you about the second postulate of Bohr. Just now it said that electron at certain energy level has certain amount of energy, or the energy of electron is quantized. Quantized. It means that energy of electron has a specific value. Dia ada tenaga yang tertentu. Okay guys, look at this diagram. So actually you pernah lukis, you pernah belajar lukis. So this is the nucleus of an atom, and then you draw the shell, the petala. Kalau zaman sekolah dulu you panggil petala, tapi dekat matriculation we are going to call it as energy level. Energy level. Okay, so we have 1, 2, 3, 4. Kita ada 4 shell atau petala. So this is the first energy level, second energy level, third energy level, and this is the fourth energy level. So dia boleh lebih lagi daripada 4. Okay, for example, focus on this electron. This electron, okay, dia move around the nucleus, okay, at the first energy level. Nampak? Dia hanya bergerak mengelilingi nukleus sahaja. So it will has certain amount of energy. So dia ada energy dia yang tersendiri. Okay. While if you look at this electron at fourth energy level. Dia berada pada petala yang keempat. So jika dia berada pada petala yang keempat juga, dia ada amount of energy dia yang tersendiri. Tak sama jika dia berada pada petala pertama, kedua, ketiga dan keempat. So jika elektron tu berada pada different energy level, it will has certain amount of energy. So how to calculate the energy? Okay, so actually you akan guna satu formula which is En equal to negative RH. What is RH? RH is Rydberg constant. Dekat mana nak dapat nilai dia? Kejap lagi saya tunjuk. Okay, times with 1 over n squared. N refer to the energy level. For example here, this electron, how to calculate the energy? Negative Rydberg constant 1 over 1 squared. So 1 squared refer to the first energy level. While if you look at this electron, the energy level is 4. Sebab dia berada pada petala yang keempat. So kita masukkan 4 dekat sini. So times with Rydberg constant, you will get the value of energy at the first energy level and the fourth energy level. So look, the value here tak sama guys. Okay, so that's why energy of electron is quantized jika dia berada at certain energy level. Okay, so bermaksud jika dia hanya mengelilingi nucleus like this is what we call as stationary state. Dia berada pada satu tempat sahaja. Dia tak ada move from one energy level to another energy level. So this is what we call as energy of electron is quantized. Okay guys, now I will explain to you about the third and fourth postulate of Bohr. Just now the third postulate said that electron move in an allowed energy state will not absorb or radiate energy. So, if the energy is emitted or absorbed by electron hanya berlaku jika dia buat perubahan from one allowed energy state to another, like this. Okay, so contoh dekat sini awak boleh lihat untuk elektron yang pertama. Okay, ini saya bulatkan so awak boleh nampak this is the first electron. Okay, elektron yang ini kalau awak lihat starting point dia at the first shell and then dia buat transition from the first shell to the fourth shell. So ini yang dipanggil sebagai electron make a transition from one allowed energy state to another. So bila dia naik kelas daripada level pertama dia naik kepada level keempat. So macam you all naik tangga, kalau you all naik tangga you kena perlukan tenaga. Kalau you tak ada tenaga you tak boleh naik tangga. Macam tu lah. So when electron make a transition from lower energy level to higher energy level, this electron need to absorb energy. But if you look at this electron the starting point at fourth energy level and then it will make a transition from fourth energy level to first energy level. See? So dia menurun. Macam kita kalau turun tangga kita perlukan tenaga banyak tak? Tak. So bila dia turun, okay, from higher to lower energy level, it will emit energy or radiate energy. Dia akan membebaskan tenaga. Nampak ni? Ini adalah pembebasan tenaga. Okay? So, the formula that we are going to use to calculate the energy emitted or energy absorbed is this formula. Delta E equal to Rydberg constant 1 over N1 squared minus 1 over N2 squared. So how to use this formula? Later I will teach you how to calculate the transition of electron ataupun the change of energy of electron after this. Okay, so you kena faham apabila dia mengelilingi nukleus without make a transition, dia takkan bebaskan atau serap tenaga. Dia akan bebaskan, elektron akan bebaskan tenaga atau absorb energy jika dia buat transition from one energy level to another energy level. Understand? Okay, based on the fourth postulate just now, we know that the energy released or energy absorbed equal to the energy difference between two energy level. Okay, so the formula that we are going to use is this formula, which is delta E equal to E stand for energy equal to Rydberg constant. So this is the value that you need to know. Okay, you tak perlu hafal because dia dah diberi dalam list of constant value, which is 2.18 times 10 power of negative 18 joule. 1 over N1 squared. So N1 refer to the initial. Maksudnya N1 ni adalah tempat permulaan elektron. Sama ada lower energy level or higher energy level minus 1 over N2 squared. N2 squared final dia, kat mana tempat elektron tu sampai. Okay, contoh macam tadi, kalau dia bergerak daripada first kepada fourth energy level, bermaksud N1 dia adalah 1, N2 dia adalah 4. Tapi kalau dia bergerak dari 4 fourth energy level kepada first energy level, so N1 dia adalah 4, N2 dia adalah 1. So you need to know the movement of electron from where to where. Okay, so actually we have another formula here. Delta E also can be calculated by H times nu. What is H? After this I will explain to you. Or Hc over lambda. So we know that nu and lambda we can relate with speed of light, which is c. Delta E also known as energy of a photon. Photon apa? Photon tu sebenarnya adalah cahaya atau tenaga yang telah dibebaskan oleh elektron. The energy emitted or absorbed is in a form of photon, thus it has specific energy and wavelength. Okay, so other than formula yang tadi, okay, saya nak explain kat sini formula yang lagi satu tadi, delta E equal to H nu equal to Hc over lambda. Okay, just now we know that the relationship between wavelength and frequency. So this is the formula that relate wavelength and frequency. Actually kita boleh relate juga dengan change of energy. Nu refer kepada frequency, lambda refer kepada wavelength. So the speed of light actually the constant value, and same with H. H adalah Planck constant. So the value is 6.6256 times 10 power of negative 34 joule second. Okay, so all this value here you tak perlu hafal because we have in the list of constant value. So ini adalah formula yang you boleh guna if you want to calculate the change of energy. It must depend on the question. Okay, so this is the difference between ground state and excited state. Okay, ground state, what is ground state? So ground state actually when n equal to 1. Tapi tak semestinya juga kelas. Tidak semestinya n equal to 1. Sometimes dia boleh jadi n equal to 2. Depends on the transition or movement of electron. The lowest allowed energy state, yang paling rendah lah, okay? And the most stable energy state. So kita tahu biasa tempat yang rendah memang stable compare tempat yang tinggi. The electron closest to the nucleus. So lagi dekat dengan nucleus. Okay, next we have excited state. So excited state bila elektron tu berada pada higher energy level, higher than ground state. So kalau ground state elektron tu 2, higher dia mungkin 3, 4, 5, 6, macam tu. Okay, so a level of an electron occupied after absorbing an amount of energy. Stability of electron decrease. Kenapa dia decrease? Sebab kita tahu lagi tinggi energy level, so dia lagi jauh daripada nucleus, so dia jadi kurang stable. Macam kita lah, kalau berada kat tempat tinggi, kita akan jadi tak stable. Okay, so the value of energy, if you want to calculate energy at the ground state and at the excited state, so you can use this formula. Actually, I already explained how to use this formula. So this formula, if you want to calculate the energy of electron at certain energy level only. Okay guys, so this is the list of selected constant value that you need to know. Okay, so you tak perlu hafal all the list of constant value sebab nilai-nilai semua ni akan diberi dalam exam, same like your table relative atomic mass. Okay, so tolong familiar dengan benda-benda ni lah. So mungkin ni benda baru bagi you all lah. Alright guys, so now we look at the example, how to use all the formula that I show you just now. So this is the first example. So what we need to do, we need to read the question first and take out all the information. So 1 mole of electron drops. Okay, see, drops. Drops maksudnya from higher to lower, from 4th energy level to 3rd energy level. It means that the electron drop from 4th energy level, n equal to 4, to n equal to 3. So this is the electron. Dia jatuh daripada higher to lower. Higher dia adalah 4, and then the 3rd energy level adalah our ground state. And the first question asks you to calculate the energy of electron at the fourth energy level. Maksudnya semasa elektron tu berada pada higher energy level, which is 4. So, which is the formula that we need to use? What is the formula we need to use here for the first question? So, we are going to use this formula, which is En equal to negative Rydberg constant 1 over n squared. So, you just substitute all the value. So, we have the value of Rydberg constant just now, 2.18 times 10 power of negative 18. So, n kita adalah 4. 4 squared, and then press your calculator. So, you will get the answer is negative 1.36 times 10 power of negative 19 joule. So, unit of energy adalah joule. So, don't forget to write the final answer. Okay, the unit. Okay, next question B. The energy of photon emitted. See, emitted. Emitted maksudnya dibebaskan. Okay, from the transition. Okay, transition maksudnya pergerakan daripada satu energy level kepada satu energy level. So, it means that this question asks you to calculate the value of delta E, the change of energy. Maksudnya daripada elektron tu bergerak fourth energy level to third energy level. So, the suitable formula that you need to use is delta E equal to Rydberg constant 1 over n1 squared minus 1 over n2 squared. So, n1 kita siapa? Kan? So, you need to know which one is our n1 and which one is our n2. n1 should be the higher energy level ataupun the starting electron tu dekat mana? Dekat n sama dengan 4. Kemudian dia drop to n equal to 3, the final. Okay, and then you just substitute all the value, so you can calculate the value of delta E. So, Rydberg constant sama juga, 2.18 times 10 power of negative 18 1 over n1 squared. n1 adalah 4. 4 squared minus n2 squared, 3 squared. Okay, and then press your calculator. So, you will get the answer in negative value, negative 1.06 times 10 power of negative 19 joule. See, why the sign is negative? Kalau you tekan calculator, memang you akan dapat negative. So, this negative sign refer kepada energy emitted. Negatif refer kepada energi atau tenaga itu telah dibebaskan. Sebab kita tahu kalau elektron make a transition from higher to lower energy level, it will release energy. So that's why you akan dapat the value in negative sign. Tapi kalau elektron tu dia move from lower energy level to higher energy level, you will get your answer in positive value. Why? Because the electron need to absorb energy. So that's the difference. So be careful, guys. Okay, next question C. We want to calculate the frequency of this photon. So, we already calculate the value of delta E, and we know that frequency ada satu formula that relate with delta E, which is the formula is this formula, delta E equal to H nu. So, you just rearrange this formula, become nu equal to delta E over H. H is Planck constant. Okay, and then you just substitute the value of delta E, and be careful, guys. Okay, negative only refer kepada energy emitted. So, negatif tu tidak perlu diletakkan di dalam formula ini. So, negatif tu hanya merujuk kepada pembebasan tenaga sahaja. Okay, divide by 6.624 2.56 times 10 power of negative 34. So this is the Planck constant value, and then press your calculator, you will get 1.6 times 10 power of 14. Unit of frequency, either you write per second or you can write as hertz. Okay, so remember guys, frequency nilai dia tak boleh negatif. That's why we need to ignore the negative sign here when you substitute in this formula. Frequency tak boleh negatif. Wavelength juga tidak boleh negatif. Panjang gelombang kelas. Wavelength tu panjang gelombang. Macam you all ukur tinggi you all lah. Pernah ke ukur negatif 1.6 meter? Tak ada kan? Okay, so frequency and wavelength cannot be in negative value. So negatif hanya merujuk kepada energy sahaja. Okay guys, that's all for this part of subtopic 2.1. Later we'll continue with the second part of this subtopic. Bye guys, thank you.